Before I do question 4.2, I just want to point out that the units of moles per decimeter cubed on 4.1 that I missed off on the last video. So I've got moles per decimeter cubed, moles divided by decimeter cubed as a concentration. I've got 4 concentrations on the top and I've got 3 concentrations on the bottom. So 4 concentrations on the top divided by 3 concentrations on the bottom leaves 1 concentration on the top, 1 mole per decimeter cubed on the top. Let's have a look at 4.3 then. So what have I got? I've got an equilibrium, an expression for the equilibrium constant. Equilibrium constant is concentration of C to the power 3, concentration of D, divided by concentration of A squared, divided by concentration of B. So let's put those numbers in. So let's put the numbers in. I've got a value of 116 for K. I've got a value of C, I've got a value of D, and I've got a value of B. I've not got A. I need to find A. So what I can do first of all is I can move A squared across the equal sign from the bottom up to the top, and the KC across the equal sign from the top down to the bottom. So I put the KC on the bottom there by moving it across the equal sign down onto the bottom, and I've taken the A squared from the bottom up to the top. So now I've got an expression for A squared. I've got the concentration of C is 1.05. I've got the number of moles, by the way, so moles is concentration is moles divided by volume, and I need to divide by the volume. The volume is 5.00, so 5 times 10 to the power of 2 centimeter cubed. We've got to get into decimeter cubed, so I divide by 1,000 to get centimeter cubed into decimeter cubed, 0.5 decimeter cubed. And so I can divide each of the moles of C, the moles of D, and the moles of B by the volume. The reason I need to divide by volume is because I've not got equal number of moles on each side. I've got 2 moles of A and 1 of B, so that's 3 moles on the left, and I've got 3 moles of C and 1 of D on the right. I've got 4 moles of D on the right, so the volumes won't cancel when I divide by them because I've got different numbers of moles on each side, and so when I divide by volume that will need to be done. A squared is 0.029289, square root it 0.17. It's got to be to 2 significant figures because I've got some of the values to 2 significant figures, such as 0.21, 0.076. So my lowest value, so some of the values are to only 2 significant figures, so it needs to be to 2 significant figures. Justify the statement that adding more water to the equilibrium mixture will lower the amount of A in the mixture. That's difficult for 3 marks. So first of all, you need to say that adding more water will lower the concentration of everything. Then what it does is, Le Chatelier's principle says opposes any change. So any lowering of concentration means that the concentrations have got to rise. It needs to make more moles of chemicals. And the side that's hit most, the side that's most affected, if you lower the concentration, is the side on the right because that's got more moles. 3 add 1 is 4 moles. On the left, there's 2 add 1 is 3 moles. So on the right, the lowering of concentration affects the right more than it does the left because there's more moles on the right hand side. So concentration needs to be raised by making more moles of the right hand side because it shifts to the right hand side because the right hand side has more moles and needs more moles making because the concentrations have been lowered by the addition of water. Tough question that.